I'm in the middle of a newly planted lavender field in an island on the Mediterranean where the conditions now are so hot and dry that the usual crops that people have been farming here for centuries don't do well anymore. So farmers are turning to new types of crops that are resistant to these really dry and hot conditions, such as lavender, which is an herb that is used in essential oils and in soaps and in perfumes that doesn't need to be watered at all. So you can see here that people are turning to new sources of income, adapting to the changing climatic conditions. Hello, welcome back. This is lecture 23. It is the second part of our two-part lecture series on climate. It corresponds to chapter 11. And last lecture, we started with the definitions of climate and how climate differs from weather. Also, how scientists gather information that help to measure changes in climate. In this lesson, we will begin by discussing natural fluctuations in climate change. So what has caused the Earth's climate to change even before humans were around? We'll talk more about climate indicators, and then we will wrap up with some more optimistic news about climate, which is what we can do about it. If there wasn't anything to do about it, there would be no reason for us to have this lecture. So there's still time. Let's get started. More headlines reflecting the dramatic impact of climate change. Hottest day on record in Northern Europe. Dozens dying in floods in Brazil. Heat waves so intense that they are causing runways, roofs, and bridges to melt and pipes to burst. So are humans solely responsible for the climate catastrophe? Well, no. Climate change has been around since the formation of the Earth, billions of years before humans walked the planet making messes. The climate has always changed naturally, including times when the whole planet was covered in ice, during the so-called snowball Earth 700,000 years ago, or when it was literally hot enough out to melt rocks, during the early Earth, when there were constant collisions with other planetary debris, like the one that resulted in the formation of the moon. The global temperature then was 3,680 degrees Fahrenheit, or 2,026 degrees Celsius. So what are some of these natural, non-human driven mechanisms that cause climate change? Well, the main one is the greenhouse effect, which has been around since the beginning of Earth's history, for as long as there have been gases in the atmosphere, really. Certain gases trap radiant heat from the sun that bounce off the Earth's surface, preventing them from escaping into space, and this causes the warming of the globe. If it weren't for the greenhouse effect, the planet could not sustain life, as it would be 60 degrees Fahrenheit cooler, so about 16 degrees Celsius cooler, which means that if the baseline temperature we established, the average for the whole planet, is about 14 degrees, the average would have been negative 2 degrees Celsius, so below freezing if there was no greenhouse effect. So the average temperature of the whole planet would be negative 2 degrees Celsius, which would not sustain life. So this diagram shows a visual representation of the greenhouse effect, which is the principle that greenhouses in agriculture are based on. The atmosphere allows solar radiation to pass through to the Earth. Some solar radiation is then absorbed by the Earth's surface, while the rest is reflected. These rays that are reflected have less energy than when they were originally radiated from the sun. Some of these will still be able to penetrate the atmosphere, while others will be absorbed by greenhouse gases and re-emitted in different directions, causing this blanket effect over the planet. The higher the concentration of greenhouse gases, the more reflected rays will be absorbed and re-emitted by the atmosphere, and the greater the global warming. The way Earth rotates and orbits around the sun also affects its climate. These patterns of rotation and shape of the orbit change naturally, causing the climate to fluctuate as cycles. The shape of the Earth's orbit, for example, changes every 100,000 years. The Earth's tilt changes every 400,000 years, and the direction of the rotational axis every 26,000 years. These patterns change the amount of solar radiation that reaches the Earth and its atmosphere. They are called Milankovitch cycles, named after this handsome young fellow seen here as a student about your age, who was the Serbian mathematician and climatologist who first described them. This graph shows global temperature patterns for the past 800,000 years derived from data obtained in ice cores. You can see the Milankovitch cycles, these natural fluctuations in global climate, until it gets to 0 years in the axis, which represents the year 1850, which is when accelerated climate change began. This next graph also shows the Milankovitch cycles, this time highlighting in gray the areas when Earth was going through a warm period. The top line in blue shows the concentration of carbon dioxide in the atmosphere. The one below in red shows global temperature. So you can see how closely the patterns of change in the carbon dioxide concentration and temperature align, how they correlate. And here a third line is added, the data for sea level rise, which also supports the same correlation. It shows that they all go hand in hand and point to the same evidence of carbon dioxide increasing, causing global warming, and in turn causing sea level rise. So here's a little exercise for you. You don't have to submit or anything, but really do make yourself just pause the video and try to figure out what goes with what. So there are some words here. They all have to do with climate change. And what I want you to do is try to figure out which word goes with which definition when I show you the definitions next. So the definitions will be mixed up and you have to figure out which word goes with what. Okay, so which one does continental drift go with? Albedo, composition of biosphere, ocean currents, and eruptions and asteroids. So they are all linked to climate in one way or another. Pause the video here and try to figure out which goes with what. I will show you the answers on the next one. Continental drift goes with E, affects how heat is distributed across Earth's crust. For example, if continents are clumped together, you have these cold interior regions forming. Albedo goes with C. Reflective surfaces like sea ice help cool the planet by reflecting radiant heat back to space. So these are going to be the white surfaces like snow and ice. Composition of biosphere goes with B. Shapes long-term climate by adding or removing the amount of CO2 in the atmosphere. So when there are more swamps that act as carbon sinks, there's less CO2 in the atmosphere, and this has a cooling effect. Ocean currents goes with D. Act as conveyor belt for heat. Big glacier melts could stop conveyor belt and lead to cooling. And lastly, eruptions and asteroids goes with A, as they release ash into the atmosphere, blocking solar energy and cooling the planet. So could humans manipulate climate in the reverse direction? Could we actually cause cooling of the planet? Not just slow global warming, but actually cool the planet with technology to reverse some of the effects of global warming? Well, this is the idea behind the field of geoengineering. What are some examples of geoengineering practices? Well, some are low tech, like painting building rooftops or roads white to increase the albedo effect and decrease the amount of radiation that gets absorbed by the earth. Other more controversial, perhaps, practices are using giant space mirrors attached to satellites to reflect solar rays before they enter the Earth's atmosphere. Cloud thinning, which is releasing ice crystals into the atmosphere to break down these really dense cirrus clouds. Releasing white aerosols high into the stratosphere so they reflect sunlight. Spraying salt into clouds to also increase reflection. Genetically engineering crops to have a more shiny surface so they can reflect more light. And creating large surfaces of microbubbles on the surface of the ocean so they make the ocean more reflective. We certainly have the technology to do most of these things already. They're really pretty simple. The question that is controversial at the moment is whether we should or not, because the implications could be huge. For example, who decides what technology should be applied where? Who controls geoengineering that could potentially affect the whole planet? Can we account for all the indirect consequences forcing the climate the way we want it to go? Nature is delicately balanced. The sudden cooling of global temperatures could have as much negative impact as sudden warming. On the other hand, some scientists are assuring that the effect of releasing aerosols into the atmosphere to cool the planet would be fairly short term, maybe a few months to a couple of years. So it might not be as risky as the long-term effects that human-induced global warming is having. Definitely some food for thought. Quick recap here, thinking back to our first lecture on climate. What are some indicators of climate change that scientists monitor around the globe? Measurements that are taken to build climate models and that are showing accelerated global warming. What are some of these? The 10 main indicators monitored by NOAA are seen in this diagram. Things like extent of sea surface, extent of sea ice, surface sea temperature, air temperature, and snow cover. I have also included these 10 climate indicators as a list on this slide. Make sure you understand how each factor points to increased global temperature. For example, snow cover in the northern hemisphere is starting to decrease. The area covered in sea ice in the Arctic each summer is shrinking, and glaciers are losing ice mass. And here's the rest. So why do we need to measure so many different factors? Well, because they each provide one more piece of evidence to show that climate change is happening at unprecedented rates. The more evidence we have, the more sure we can be of our models, our explanations of what is happening and why, and predictions of what will happen in the future. Other climate indicators measured include droughts, amount of precipitation, distribution of marine species, ocean acidity, and length of growing season for crops in different regions. Note the word that I just used, measured. These are all numbers. They are all facts. You can't argue with how many days of temperatures over 90 degrees happen in one summer in the continental US. It's a number. It's not an interpretation or an opinion. You just count the number of days, which is what makes it strange when people refer to believing or not in climate change or that it's a hoax. It's really just numbers. And again, the graph showing a steady increase in temperature above the established baseline since the 1800s. So the impacts of climate change on nature and on human society is something we're all familiar with by now, based on our own experience and from daily headlines around the world. I provided just a glimpse of some examples at the beginning of this and the previous lecture. Let's go through some of the main impacts. So rising sea level is a global problem, even though it is not uniform everywhere because, of course, the Earth's crust is uneven. So some places like the eastern coast of the US are going to experience more sea level rise than the western US. Coastal cities and island nations are particularly vulnerable, and in many cases, like towns in Louisiana and islands in the Pacific, whole communities have already been moved or are in the process of moving inland. Sea level brings higher risk of flooding and also things like saltwater intrusion, which remember is when salt water from the ocean enters freshwater wells, deeming them unusable. Flooding due to sea level rise can be observed in cities like Miami, where streets are flooded even if it hasn't rained, just due to the rising tides. This is known as sunny day or nuisance flooding. And this graph shows variation in sea height since the 1990s. Amongst the tools available to the public for understanding climate change impact is this sea level rise viewer, which lets you search for a place in the United States and see the extent of flooding based on different degrees of sea level rise and which parts of each city could be affected. Let me show you. So let's look at Charleston, for example. Okay, there's Charleston. On the bottom left is the slider that allows us to move the sea level height up different feet, like this. So let's do a conservative 3 feet and zoom in to see which neighborhoods would be affected. The darker blue, the deeper the water. So the darker the blue, the deeper the water. And also bright green indicates potential flooding as well. Even though these are areas that are not directly linked to water, connected to water, they are low-lying, so they're also at risk of flooding. And if you want to know more about what you're seeing, you can click this little eye for information over here on the bottom left, which brings us this panel. You can close it too. And then on the top right corner, you see this, the legend. Tells you what they are. So if we zoom into Charleston, we can see that if the sea level were to rise another 3 feet, all these neighborhoods, look how densely populated there's all these houses and buildings. All these neighborhoods around Colonial Lake are going to be flooded. Playgrounds, a children's hospital right here, a high school. You can see the degree of the impact. Okay, so that's just 3 feet. If you click on vulnerability, it gives us the communities that are the most vulnerable and would be impacted by this much sea level rise. And this is based on social and economic data. So if you go vulnerability right here, you can see that the darker red are the communities that would be most impacted by this sea level rise. And again, you can click the I for more information. So it's a really fairly easy to use but very powerful GIS tool. You can add different layers, you can focus on different things. Connecting back to our chapter on environmental justice at the start of the course, recall that these vulnerable communities are most affected by environmental disasters because they have less means to be resilient, to bounce back. Low-income housing is built cheaply and in areas that used to be old marshes, for example, and these would be first to flood. There is less money for litigation and the government is slower to react. So we need to make sure that resources are allocated accordingly to help people in these communities who are at a much higher disadvantage for tackling the effects of climate for no fault of their own. And more headlines around the world related to sea level rise that you can read about. The numbers of extreme weather events is also increasing with climate change due to the oceans carrying more energy, which is what feeds these intense storms, bringing more rain, hurricanes, flooding, and destruction of marine and coastal habitats. NOAA is just one of the institutions that keeps track of everything related to extreme weather events. These records help provide information to feed into climate models so that we can then make predictions of what could be in store in the future. And here you can see other numbers tracked by AccuWeather. And an example of extreme weather events that are more common now is what you might have heard of as a bomb cyclone. Let me just show you what happened in that one in California recently.
Let's check in with CBS News meteorologist and climate specialist Jeff Berardelli tracking the severe weather. Jeff?
Good evening, Jamie. Good evening, everybody. We call this weather whiplash, to go from the worst drought in modern history and in the snap of a finger to a record-breaking storm system along the West Coast. To give you an idea of how wicked this jet stream is, over the open ocean, we have 30 to 50-foot waves. That means very rough surf expected along the West Coast. Now, it's all due to a fire hose of tropical moisture, concentrated band of tropical moisture that'll be shooting its way, slingshotting its way into the central coast of California. The storm to the north of it will be the equivalent of a Cat 3 hurricane. That means gusts along the coast up to 80 miles an hour, and that band of heavy tropical moisture moving down the coast as we head through tonight and during the day tomorrow as well. So here's a look at your hour-by-hour forecast. Look at how intense this rain is. We do expect to see flash flooding and debris flows. In fact, it's looking like it's going to be a very dangerous situation for the next 24 to 48 hours. Maybe an inch of rain in Southern California, but in Central California, 4 to 8 inches of rain.
So with extreme rain comes severe dryness in other places because this water has been collected from somewhere else in the water cycle. This causes severe droughts throughout the globe and not necessarily just in places that are normally very dry. The National Drought Mitigation Center at the University of Nebraska maintains a drought monitor, including things like a drought monitor map for the nation, which gets updated every week, interactive maps that you can customize to view comparisons of droughts at different times, summaries of drought conditions for the main regions of the U.S., and things like links to prediction models. So I've included the link so you can check it out, the drought monitor. And there is also a global drought monitor, free tool available to view conditions across the world. Climate change also means the loss of many of the ecosystem services we depend on. Ocean acidification, for example, and higher ocean temperatures mean destruction of marine habitats and unbalance of food webs that provide a big part of the world population with food. Loss of phytoplankton means less oxygen produced. And right now, our main source of oxygen in the atmosphere is phytoplankton. Breeding, flowering, and migration changes in species affects biological activities, like, for example, pollination of crops, an ecosystem service that we depend on in agriculture. And dry soil means that water cannot be filtered as well through it, and nutrient cycling slows down, which unbalances these biogeochemical cycles we talked about. And the behavior of land species of plants, animals, and fungi are all going to be affected, and they play important roles in nature. Human populations also suffer huge economic losses, as you can see in this example of $1 billion or more weather and climate disasters. And this is due to rebuilding after extreme weather events, things like disaster mitigation and prevention. And of course, the hundreds of millions of dollars that climate impacts are causing us doesn't include the human toll. So now, what are we doing about it? Well, quite a bit, although many would argue that probably not enough. Towns, cities, whole countries are evaluating their situation, their contributions to global warming, their disaster preparedness, their resources for fighting climate impact, and they're coming up with their own action plans. For example, China and many cities, including Boone, and countries around the world are pledging to reach carbon neutrality, which means their carbon emissions would equal the carbon that they reduce. So for example, by doing things like restoring wetlands, planting more trees, carbon capture, turning to renewable energy, and so on. Now, some plans are more aggressive than others. Others are more realistic, but in most places there is talk of some sort of climate resilience plan. And for example, you can read about App State's plan for carbon neutrality in this link I provide below. So what can you do now, and what can we do now? So as an individual, you can think about ways that you can reduce your own carbon footprint. Some that are realistic, like don't make these big plans that are not going to be sustainable. Start small with things like composting or buying second-hand clothes that anyone could do. Think about the amount of raw materials that go into making a new item of clothing, the energy and extraction, manufacturing, and transport that is used versus if you just buy something at a thrift store or recycle clothes among friends. For example, to make a cotton t-shirt, you need to grow the cotton seed, which involves lots of water, labor, fertilizers, tractors. There's a lot of people involved. Then the processing of these plants and the amount of energy and resources that goes into turning the cotton balls into thread, the chemicals that are used to dye it and then sew it together. You have to package it, transport it to shops, and then think about all the waste material that goes into the process as well. And the same for anything else you use. So think in terms of waste, energy, and transport, and the raw materials that are required. And most importantly, stay informed. Pay attention to only trustworthy sources and use your voice to vote. Like Dwight says, you can't change the whole world, but you can help make it a bit better. But climate impact is a global issue that needs to be addressed globally. Because we all share the same atmosphere, oceans, and resources. So it needs to be tackled globally in order for significant change to be made. So in 1988, a task force called the Intergovernmental Panel on Climate Change, IPCC, was created, made up of 195 countries. It's part of the United Nations. It gathers data from around the world and creates a report that comes out every 6 or 7 years, which describes the state of the world with regards to climate and provides data that governments can use to make strategic plans. It involves hundreds of people working together. And this is what got Al Gore the Nobel Peace Prize in 2007, his work on this. And then representatives of most countries around the world, all except for Iran, Libya, and Yemen, get together once a year in a big meeting called the Conference of the Parties, or COP, to share things like what their country's goals for carbon emission reduction are, what they need help with in terms of climate mitigation and resilience, goals for the following year, and so on. It's where climate pledges are made and collaborations are established. For example, at the COP27, which took place in 2022, many countries joined the US and the European Union to make pledges to cut down their methane emissions. But some, like Australia, refused to, partly because they're now building new fossil fuel power plants, unfortunately. The Paris Agreement, the international agreement by which countries agree to take measures to tackle climate change, that was signed during COP21, I think it was, is a voluntary agreement, which means every country sets their own goals and it is up to their government and not other countries to enforce them. It is voluntary. So it's always a big accomplishment when many countries agree on something. For example, one of the main things to come out of COP27, the 2022 meeting, was the establishment of a loss and damage fund to assist developing countries that are particularly vulnerable to effects of climate change. So developing countries are still falling short of contributing to this 100 billion pot of money that was pledged globally for climate action and adaptation, but committing a specific fund to go to paying for loss and damage that has already been suffered by developing countries is a really big deal. What is really neat, I think, is that students can be a part of these Conference of the Parties as observers and learn about what countries are doing and see the lead up to the negotiations in person. The year 2022 was the first year that App State had passes to attend the Conference of the Parties, and a group of students and faculty traveled to Egypt to COP27. So some of you might be interested in applying for this climate negotiations course, through which you get to attend the Conference of the Parties meeting that year. And if you want more information, I have included an example of a course flyer. I think this was for fall 2023, but it also has the QR code or the link below to the App State page for App State to COP. And there's also a little video here that goes more in depth into what an IPCC report looks like. With all the data, technology initiatives, and passionate advocates we have to tackle the issue of anthropogenic, human-driven climate change, there's always the need for new ideas. So check these out. Feeding algae to cows to reduce methane, installing giant planters with composting toilets incorporated in them in Amsterdam for more sustainable public bathrooms, probably for people that have penises. I don't know how you would do it otherwise. And a pedal and sun-powered mobile ironing service in India. So will your idea be the next big thing in climate mitigation, adaptation, or resilience? You don't have to be a climate scientist to come up with a great idea. And to end this lecture series on climate, I wanted to make another connection to a topic we've just covered, that of feedback loops in the previous chapter. And remember that feedback loops can either be reinforcing, or positive they're called, or balancing, negative. What do you think this one is? So for example, ice cover in the Arctic reflects sunlight and therefore prevents the warming of ocean water. Each year, as less ice accumulates, more sun reaches the water and heats it up, leading to less ice, warmer water, and even less ice, and so on. What do you think this one is? You can pause it if you need a minute. Is it negative or positive? And the answer is, it's reinforcing. It's a positive feedback loop. Let's look at it as a diagram. So you have the vanishing sea ice is causing more Arctic sea ice to melt, which in turn is causing the reflective ice to disappear, making the darker ocean absorb more heat, which is going to mean more ice vanishing, and so on. So it keeps reinforcing, it keeps adding up, more heat of the ocean, more sea ice disappearing, higher the temperature, and so on. Another reinforcing loop related to global warming is the warming of peatland. So the warming of peat causes the warming of wetland peat. And here the bogs are going to release methane as the peat warms. Methane is a potent greenhouse gas. Therefore, more heat is absorbed and emitted by the atmosphere, causing more peatland warming, causing more wetland warming, more peat in the wetland to warm, and the bogs to release more methane, and so on. Okay, I have one more mini interactive for you for this chapter that is going to encourage you to try one of the tools that I mentioned in these videos. I'm going to show you a Padlet that I created in a minute, and you are going to add a sticky to it like you have done in the past. Let me just give you these 3 points that are up here on the screen before I show you the Padlet. I'd like you to include a screenshot or a picture showing something you learned while using the tool. I don't want more than 12 people per tool, otherwise we're going to have everyone picking the same thing. Okay, so if one is maxed out, then go on to pick another one. And make sure your name appears as the title of your post. So let me show you what the Padlet looks like. It looks like this. There are 4 tools featured: sea level viewer, drought monitor, global vital signs, and then this one that I haven't mentioned in the presentation, but I think you're going to find interesting. So you can click on any of these boxes. Okay, I'll do the states at risk since it's the only one you haven't seen. It's going to take you to a dashboard. It's all interactive, okay? So for this one, for example, you are going to learn about the grades, as in like report cards, that states get based on their climate preparedness or their climate risk. So you can pick, for example, any state in the United States, like Nebraska, okay, and you see what it's going to get in terms of climate preparedness. So it gets a D+, so maybe you can read about why. And you can also pick the different icons up here or in the other page to focus on specific things. So for example, you can pick inland flooding and see which states are going to get the best grade in terms of their preparedness for inland flooding. Okay, and you can see what the key means. So which ones are the best prepared, which ones are the worst prepared. Okay, so this one focuses all about their preparedness. Okay, so pick one of the 4 tools. You don't have to spend more than like 15 minutes on this. Just click on one, investigate the interactivity of it. Don't just like open it, take a snapshot and leave. And then include in your post just a couple of sentences about what you learned. If you have any questions, just let me know.